In this video, I'm going to talk about how we developed the idea for our installation, as well as how our installation links together mathematics and visual arts. So the first thing that I did when we got this assignment was start to think about my artistic influences and starting to seek some inspiration as well. So I've always really liked the idea of found art. And I think what attracts me to found art is that idea of environmental sustainability, like that you don't need a whole lot of resources and expensive equipment in order to make something that is art. And I also really like the idea of finding beauty in the everyday. So another thing that I went and did was I went to NGV, and when I was there I saw an installation by Carlos Amorales. And what I really liked about that installation was that it was very dependent on audience participation. So without that audience participation, it was really just a stagnant object. So on the way home from NGV, I took the train home and we were going past all of these backyards, and I just got this split-second glimpse of a Hills hoist in someone's backyard, and it just triggered a memory for me just of my parents' old Hills hoist when I was a kid. And so then I started thinking about how the object of the Hills hoist could become an artwork. And so from there I thought, because the Hills hoist had triggered a memory for me, maybe this object could become a catalyst for other people sharing their memories. So the next thing that I had to do was to find some links between mathematics and visual arts. There's lots of people that talk about the benefits of cross-curricular education. Firstly, it's closer to real life, so there's not many situations outside of the classroom where you only use one domain. It also allows you to use the strengths of one subject to understand another, and it's also practical in terms of time. But when you are taking this integrated approach, there are also some dangers. So one of those dangers is service connections. So this is where you're using one subject to enhance another without the concepts or outcomes of both of those subjects really being covered. So what needs to happen is there needs to be a shift. So you need to be able to sometimes be looking at the mathematics within the installation and sometimes be looking at the art outcomes within the installation. So you need to practice what Barnes calls some subject selfishness, so that no one subject is dominating the other. What I did was I tried to look for the mathematics that was already inherent within the installation. So looking at where does the maths already exist, rather than trying to put mathematics into the installation. So I knew that we had the Hills hoist, and we'd also discussed that we'd like to use some fairy lights as well. So in looking at those two objects, I started thinking about what processes am I using, what knowledge do I need, and how could these processes and knowledge be used in order to teach students about mathematics and about art. Links between visual arts and mathematics can be found at all stages of this installation, so not just in the installation itself, but also in the preparation for the installation and in its filming and its presentation. So when I was looking at the arts, I looked at the use of materials, the use of visual conventions, and also the display and the audience interpretation. In mathematics, I looked at estimation, measurement, ratio, geometry, and also angles. There's many ways that our installation was congruent with good pedagogy and best practice in education. So Gardner suggests that there are multiple intelligences and that people are often talented in one or more of the intelligences. So it makes sense to provide the curriculum in many different ways. That way students can use their strengths to help them understand and reinforce the content. So by the visual presentation of the geometric shapes within our installation, we involved the spatial intelligence. And through the creation of those shapes, so winding the fairy lights around, we were able to also involve the kinesthetic intelligence. I also looked at the 8 ways of learning, which is an Indigenous pedagogy. So I looked particularly at story sharing and non-verbal learning. So in order to erect the Hills Hoist, I actually had no idea about how to do it, and ended up having a look at quite a few YouTube videos that actually showed you this process. So I actually learnt through other people sharing their stories how to complete that part of the installation. So I also looked at non-verbal links as well. So by rotating the Hills Hoist, we were able to explore angles in a concrete way. So we didn't need to use language. We could sort of explore that concept using the Hills Hoist. Another connection was problem-based learning. So during problem-based learning or problem solving, students don't have the knowledge or the resources to solve a problem straight away. So it's something that they want to find a solution to, and they have to draw on a range of strategies and select one that's appropriate in order to get an answer. So that gives them an opportunity for reflection, and a lot of learning comes from that reflection. So problem solving would be particularly apparent in the process of setting up a Hills Hoist. I also looked at the work of Perry and Karen as well, surrounding concrete materials. So concrete materials help students to move toward understanding of abstract concepts in mathematics. So sometimes students will need to move back to concrete materials at different stages to reinforce or change their understanding of a mathematics topic. If this installation were to be recreated in a school, all of the same connections could be explored. While the connections that are made during the setup of the installation are somewhat finite, the connections with geometry and angles could be explored time and time again. So for a start, you could have multiple students creating those shapes. I was only able to put a few into our installation, but with more students you would be able to get a greater variety. Also, the shapes that I put into the installation weren't perfect. They didn't have straight sides and defined vertices. Students could explore materials that would actually give them these perfect lines and vertices.